sort of like being a detective, trying to put together pieces of a puzzle. And because you don't have a complete story when you're a geologist, you have to collect data here, collect data there, do some analyses, and hope it will all come together. I'm a glacial geologist, and I focus on landforms and sediments left behind by glaciers. And it's an important field to me because if we want to know how the climate's going to change in the future, we really have to understand what's naturally fluctuated in the past. And so in order to have a more accurate prediction of what's possible and what's happened, we have to study these kinds of things in the past. And so that's what I focus on, looking at landforms and reconstructing glacial history for an area, or looking at sediments and seeing how the climate has fluctuated even more recently. I'm publishing some papers in journal articles. I have one in press right now on glacial history of one of the ice caps up in northwest Iceland. The end product, of course, of any research project in a natural science is to submit a paper for publication to a peer-reviewed journal, and you want to get international journals that many people will read. So it's definitely requires a lot of effort and commitment to writing. It's not quite the same as writing a book because you have a page limit or a word limit. You have to get everything said clearly within a certain amount of words, and then you just hope it gets accepted. It's one of those things where you'll get feedback from reviewers, and some will be positive, some will be negative, and you have to revise and resubmit. Unless you're an expert right away on something, it's rare that you don't have to revise an article again and again. And this is something we try to get across to the students, that the first time you write a paper is not the last time you're going to see it. You're going to keep revising and revising it. When you're trying to come up with a hypothesis of something to test, you might have a variety of workable hypotheses. So you have multiple working hypotheses. So it's not that you just have one thing you're going to test and that's it. If you're going to travel all the way to Iceland, for example, you want to think of many projects you can try to collect data for. And some of them, your results will not be publishable. And that's okay, especially it gives a student a good experience, and they learn that not everything is actually worthy of publication. However, your goal is that your main purpose is something that will result in something publishable. And so you have multiple projects going on at one time in the sciences. It's a little bit different, again, than some of the other fields. So you'll start one project, you'll be doing the lab analyses, well then you'll do the field work for another new project the next year, and then the next summer you'll start writing up the one you started 2 summers before, and it's a continuous process that goes on, and it's not, and then once you're working on one thing, that will lead to other questions, and it seems like the more you know, the less you know, the saying goes. You keep coming up with more questions instead of answers, really, in science. That's how I feel like it works out many times. In my field, there's studies from all over the world documenting melting glaciers, and it's not a political issue, and I think that's part of the problem, is that in America it's often politicized. Climate change, either it's changing or it's not. Well, it is changing. Glaciers are melting, and sea level is rising, and the temperature of the Earth is getting warmer. So it's not a debate, and a lot of times in the media, they think they should show both sides of a story, when this issue does not really have two sides. There is debate on what's causing everything, and that's okay to talk about in a side, different components. The climate is very complex.